what we've learned from nature and all the laws and how things work, and we've integrated together to make sure that something is material as a manufacturing facility or a larger system is actually operating with efficiency. So the industrial engineer is actually equipped with technical competence. So this is why you're all going to school right now. There's some level of education that you need to make sure that you know your calculus, that you know physics and chemistry, that you can basically merge all these things together in the end. Then also, like I was saying, that we really interface also with the business enterprise itself. Again, Tim Cook is a great example. And then at the end of the day, we're really worried about what? Money, right? So it's the bottom line that we're really concerned with. So we're always looking at cost and revenue, and we're always trying to balance ourselves against these issues. So I'm just going to play a quick video right now. It's about maybe a 5-6 minute video just to give you kind of some testimonials about IEs and IEs in the workplace, and you'll even probably recognize a couple of the companies that are within this video as well.
I work for NASA at the Kennedy Space Center, assembling and testing an international laboratory in space.
My work helps patients at our hospital get better care. Every day I am improving how we make some of America's favorite treats.
Our motto is we never forget who we're working for, and who we work for is the U.S. military.
Within 10 years, every hospital in the nation will have an industrial engineer associated with their team. I help create magical moments at one of the world's most famous places.
Industrial engineers are problem solvers. People who find that it's creative and fun to make things work better.
The International Space Station travels around the Earth at 17,500 miles per hour. That's 16 times a day. 6 astronauts from different countries live there, performing experiments that would benefit life on Earth. I lead a team of people that assembles and checks out the hardware that will be flown to space, which will then be used by our scientists. This module just came back from space, and actually we opened up the hatch yesterday. As an industrial engineer, I'm contributing to one of the greatest technological achievements in human history.
I like my job because it's different every day. In this plant, we make about 1 million pounds of chocolate every day. Even in a company as successful as Hershey, industrial engineers can always help improve what we do. We ended up collecting rows of bars and looking at the almond percentage by bar. Our Hershey bars with almonds did not always have a consistent number of almonds. I led a team to make design changes to the equipment, so now the bars have a more consistent number of almonds. Now we are producing better quality bars, our customers are happy, and the company is saving money.
Lockheed Martin is the #1 defense contractor for the United States government. I'm responsible for the operations element of the missiles and fire control business. The approach we're going to take to build and test things, the manpower we're going to need, the technology support, the whole backbone of what we do is all around culture. I'll call it culture being an item. When my customer comes back and tells me that the products I made saved their lives, there's no more customer satisfaction better than that.
Industrial engineers are the kind of people that find the shortest, quickest, cheapest, best way to do something and think it's fun to solve that puzzle.
We try to strive for delivering excellence and quality in all we do.
Not only do they have good technical skills, they're good in math and science and computers, but they also have good people skills. They learn how businesses work. They learn how the world works.
They look at the whole picture, and they try to understand where it all fits.
Starting salaries now are in the $55,000 to $65,000 range. Industrial engineers are in more demand today than they ever have been.
Because there's so many things you can do with IE, I don't really feel worried about my next step in my career.
Hospitals today are busier than ever, so it's really important that each patient gets fast and quality care. As an industrial engineer, I work directly with doctors and nurses. And you find that having a standard process with a huddle has really improved your metrics as opposed to what you were doing before. We develop ideas to make the hospital run more efficiently and make procedures like lab testing more accurate. Seeing patients get better and seeing them happy about their care it really means a lot, and it makes you want to come to work every day.
I remember coming to the theme parks as a kid. I wanted to experience everything. Now my job at Disney is to make sure our parks and resorts are fun and efficient, so our guests get the full experience. I observe how our attractions are operating and analyze data to make improvements. New changes to Space Mountain are making wait times shorter and more entertaining. Think about the number of people that come through our turnstiles, and getting the opportunity to say, yep, I had a hand in improving their experience is definitely rewarding.
From the products on our shelves to the efficiency of our trucks, industrial engineers contribute to Walmart's role as a global leader in sustainability.
My job is to create technology that makes it easy to capture and share life's most important moments.
Industrial engineers help our airports operate more safely and efficiently.
I study the new and innovative ways people work today so my company can develop products for the future.
I develop new methods to keep our factory workers safer on the job.
At the American Red Cross, industrial engineers coordinate disaster relief to the world's neediest people.
I'm able to help create a corporate vision and develop a path to get there.
As an industrial engineer, I help to advance the future of space exploration.
I work for a company that builds medical devices so people can live longer, healthier lives.
Our team of industrial engineers finds the best way to transport our products to more than 1,000 stores.
My company makes equipment to diagnose all kinds of patient injuries and illness.
As an industrial engineer, I'm improving products for the global auto industry.
Industrial engineering gives me a unique and different perspective to improve the way my company does business.
I try to drive continuous process improvement every day.
Industrial engineering opens up opportunities throughout the company. You can pretty much go anywhere.
We're tackling new challenges and coming up with creative solutions to make our company better.
And all those things that I learned in my IE program, I apply every day.
It's exciting to use my industrial engineering skills to deliver a great guest experience.
My job is rewarding because I know I'm making a difference in people's lives.
Industrial engineers are the leaders of today in engineering.
Every day is a different adventure. It's truly the dream job.
Okay, so that was just a little piece to show you some of the variety that's behind people working as far as in the IT field and manufacturing. You can see it's not just necessarily manufacturing, but there's also some system elements there. One little tidbit that I'll give you is that the healthcare industry is definitely looking for industrial engineers. I mean, how many of you have been to a hospital before? You know how chaotic it can be, right? So this is something that the IE as far as systems engineering can offer, because we go in and we actually analyze processes and see how paper trails are actually moving and see where there's sort of red tape, and then we try to go take these tools and apply them to basically defog up the system. Because every time that you're spending doing something, it can be non-value added time or it can be value added. For instance, you're studying or you have an exam on Thursday, right? We'll just say yes. You have an exam on Thursday. So between now and then, you have to appropriate your time to study that. So are you going to go play, I don't know, what's the latest game now? What? Destiny? Are you going to go play Destiny for the next 4 days? Well, if you did, you would consider that non-value added time because you're a student, so you're working towards something. So everything that you're doing right now has to be working toward that degree. Everything else is just, it's non-value added. You're actually inflating your cost of what you would do to attain your final product. So that's just a little example as far as the student. So now we're going to kind of talk about the state of manufacturing, and while I'll try to convince all of you to become industrial manufacturing engineers. As you can see here from this first graph here, basically asks how does manufacturing contribute to exports. So of course, every country, right, we have products and then we export them to different countries because they buy those products, right? Well, the U.S., even though we're sort of in a down state because of the recession, we're still pretty good when it comes to actually exporting. So You can see that about 6 in 10 US export dollars actually comes from manufacturing. So this is pretty big. So there's still opportunities there. Also, how does manufacturing compare to other industries that we have in America? So you can see here that we're about the 4th largest employer as far as manufacturing, and that's expected to grow. And I'll show you why in a second. Also, the economic impact, which is something that you really have to think about, right? We want everybody to have a job. We want everybody to have a state of living that's commensurate with the whole entire population, right? So you can see here for every dollar spent on manufacturing, it actually creates an extra 48 cents. So we're the only industry that can say that. So that's really important because that means, again, we're producing over 100% as far as economic activity. So we're adding value to America, which is what you want to do overall. So this is something that I usually speak with when I'm trying to convince kids to actually stay in grad school and go to grad school, because this is sort of where we lost our prominence as far as American all. So everybody knows what a patent is, right? So you know what a patent is? Yes. No? You know what a patent is? No? So a patent is basically a document that you get certified. Usually it's on a national level. Excuse me, my phone's going off. It's an idea. And you have it on paper and you list it out. This is my idea. This is how it's done. This is all me and my partners or whoever's involved. And so the government issues you a patent that says, okay, this is your idea. So as long as you don't, say, publish this in the news or a paper or something, this is your idea, you can make a company, and you can produce your product and sell it. And you have a certain amount of time before this patent is actually licensed. And then after that, anybody else can come in. A good example of that is, say, the latest pharmaceutical drug for, say, body cancer, right? So some company has spent millions of dollars to actually develop this drug. They start to produce this drug, they make a patent, and then they sell the product. So after about 15 years, they have to basically relinquish that patent so any other company can come in. So that's usually good because usually a pharmaceutical is going to, when they sell their product, right, they're going to put a high premium on it, so they're going to sell it at a high cost. Well, another company will come in, a secondary company, they'll make the drug for actually cheaper. And so that allows it to basically get in the hands of more people. So patents are very important, especially for manufacturing, because as you can see here, this is the declining U.S. presence as far as what we call patents as intellectual property. This is usually something that a company holds. You can see that it's basically decreased from 1980 to about 2011 to where we are now, about 20%. Well, 20% is a lot, and because we're competing against other countries, right? So other countries are producing ideas, and then ideas is what we turn out to manufacture. Has anybody ever had a clever invention here? It's just some problem that you saw that you said, you know what? If I had this device, it would make it so easy, and I could probably even sell it to everybody. Nobody's here had an idea like that? No? Anything about a purse or anything like that? If I had a purse that had a flashlight in the front of it and I could just, it's a horrible example, but. No? Nobody's had any ideas? All right, we'll start thinking about ideas. One thing I'll let you know that I'm also involved in a lot of entrepreneurial opportunities. So I like to create businesses that solve problems. Usually it's a problem that's related to some materials research. So something like, a lot of companies are created, they make apps, right? I mean, how many people have played that crazy game? My wife likes to play it. What's the game? Candy Crush? Right? That game gets on my nerves, but everybody likes to play it, right? How many in here have played Candy Crush? Oh, not too few, okay. So I would consider that non-value-added time. It's not adding any value, but that's just my personal opinion. So the decline of actually having this these ideas and actually converting them into IP, which is, IP means, I'm sure everybody here has watched the Shark Tank. So IP gives you as a business or an entity, you know, a right to say, well, if you want to buy my company, then you have to pay me this dollar amount. So IP is very important. But over the past couple of years, we've lost our hold as far as our IP. So that means our ideas are going down, so we're not creating new technologies. And a country can't stand if it's not creating new technologies. That's how America has become America, because we have those ideas. And then here's just a poll. They actually went to this is also something called the Society of Manufacturing Engineers. They did a report where they went to different companies and they asked, well, what do you need? What are your needs for your company? And as you can see here, they need industrial manufacturing engineers to a large tune, as well as machinists and then also product designers. So if I'm an 18-year-old student and I see this information right here, what does that mean? I mean, just ask your parents about job security, right? Everybody here, you want a job that you can stay at, that you can be good at, and if you want to, you can stay with the company for as long as you want, right? So job security is something very important that you have to think about in the long run. You know, can I stay at this company for potentially 20 years or 30 years? So here, you know, they're saying that, you know, we need this profession. So that means that there are opportunities available. You want to go where the opportunities are, which is why we have an influx of, you know, I'm sure everybody here has, you know, some type of immigration in their family, many different ways, right? Everybody's come here for opportunities. And so that's what's on the horizon. Opportunities are there. This is just actually one of the CEOs of SME touting that we need a workforce, a new type of workforce actually. And I won't read that quote, but I'll give you a little tidbit about this new emerging sort of education or employee. It's something that's called the hybrid engineer. And it's also synonymous with something I call a knowledge worker. So most of you in here are computer inclined, right? No? Yeah. Everybody knows how to operate a computer? So if you really think about it, everything, because we're in this information age, right? And we can only process so much information at one time, right? So basically everything that you do probably is gonna have a computer interface with it, right? So you're gonna have that computer actually on the manufacturing floor. Whatever you're doing, if it's machining or any type of shop floor activity, you're probably gonna have a computer there that you can interface with what you're doing to help you do your job. So it may help you fix a problem. So maybe you go into your company database and they have a list of, you know, okay, well, we can work this out this way and such and such. So a knowledge worker is very important because it's not just me sitting at a desk and designing a product. It could be me sitting on the shop floor actually doing some machining while I'm designing the product. So I'm doing kind of everything concurrently or at once. So this is actually what we're going towards in manufacturing engineering, is actually having this sort of concurrent approach to designing and producing something. Usually it's at a faster rate, so you make a cheaper product. So recently, a couple of years ago, President Obama started sort of a manufacturing initiative. And it has to do with advanced manufacturing and also advanced materials. So now I'm going to sort of get into a little bit about Tallahassee, Florida, and what we have up there as far as a cooperation between Florida State University and also FAMU. And here are some of our known highlights, like Florida A&M. I'm sure everybody's heard of the Market 100. It's basically a famous band, even though they've had some turmoil over the last couple of years. And of course, everybody knows about Florida State University because we are the national champions. So there's a lot there. I don't think we played UCF anytime soon, but I'm sure that's coming along as well. We have pretty much a big population. It's actually more than a third of the population are students in Tallahassee. So it's a very student-friendly place. Our enrollment for FSU is about 41,000. Our enrollment for FAMU is around 12,000. Of course, that fluctuates. So we've had a new dean actually at the College of Engineering the last 4 years, and he came up with this model. It's called 2 colleges and twice the opportunities. And basically what this means is, and this is the College of Engineering, which is about 1.5 miles between each university location, so it's not too far away from the main campuses. So basically, this 2 opportunities means that we actually do a lot of undergraduate research opportunities. So not only are you building your education as far as the BS degree, but you're also getting experience if you want to achieve higher levels of education. So we have a lot of programs that involve undergraduates actually doing research with graduate students and also professors. This is key because everybody here has a resume now, right? So what is a resume for? I'm not sure why this is jumping around, but okay, I guess I'll stay on task then. We have a pretty large facility that's out of our engineering department. It's called the High Performance Materials Institute. And this is where most of our undergraduates and grad students work. We do a lot of research on composite materials and also new materials that you might have heard of, like nanotechnology. Actually, the iPhone has a lot of nanotechnology components. So these are very, very small particles that create your devices that we love to use, and this usually helps with electronics as well. Yeah, my slides are going haywire here. Mainly our focus is on composite materials, nanocomposites, and then also process and quality control, which really brings in the ID aspect. So remember I showed you that life cycle chart, right? At the beginning was we have raw materials. So the question always is with these new ideas and how we solve the problem is, what material can I use on the planet? And then in the future, some other planet. What can I use to actually turn something into something that we can use? And you can see here that we do that every day, right? You have clothes, you have cell phones, you watch TV. So all those are made of special key materials that we synthesize. So what we do is we figure out how do we synthesize these materials and turn them into something that can be of use to the public. So these are actually part of a new set of professors. On the right side there are some of our older professors that are part of the faculty. So we actually do a lot of projects. We like to keep our students engaged. And this is a product that we did actually a couple years ago before really electrical vehicles were being touted so high. So we actually built an all composite car. So this is all composite material, no metal. So it's a non-traditional process. And it's actually an electric vehicle. It actually runs on about 9 rechargeable batteries. It goes about 40 miles per hour. Costs maybe about $30,000 in total. And we actually drove it on the Daytona Speedway not too long ago. So yeah, we just like to really engage our students, give you opportunities to practice and use the engineering knowledge that you acquire throughout your years. As far as opportunities, there's opportunities as far as getting different types of scholarships and grants. Within our department, we actually have something that's very special. It's called a fellowship. Basically, it's a full ride. So how many would like a full ride to a four-year institution in higher education? If you do not have your hand up, you might have some issues, right? I mean, how many of you here are on scholarship right now? Okay, for those of you that are not, you should be. You have the opportunity to. It just takes a little application, and then make sure you treat your professors with a lot of respect, because you need something called a letter of recommendation. So, opportunities are available. Now, I'll tell you about because I did come here to actually talk about minorities in engineering as well. We have a program that we've had the last 6 years. It's called the DREAM program, and it's sponsored by the Air Force Research Laboratory. And I can tell you just from talking with a lot of people in industry that they want minorities. They want females, they want Latinos, they want African Americans. The problem is they can't find it. How many of you believe that? believe that they can't find any? You do? How? Why? How come? Because there's none? No, you're here, right? The question is, what are you doing? How many of you are on LinkedIn or something? How many of you have a full-fledged resume that's right there that if you're ever, you know, in the airport or something and run into the CEO of GE, you can say, oh, here's my resume. You know, opportunity, okay, I figured you were. Opportunities are always everywhere, and you always have to be prepared for those opportunities. So it really comes down to visibility. So during this summer program that I was talking about, we really have a hard time actually finding minorities to come in and fill the position. And that's nationwide. You guys, you can separate yourselves from everybody by making yourself visible. Don't be afraid to make yourself visible. You know, I can tell you I didn't have the best resume coming out of my BS program. I actually started at Tallahassee Community College in Tallahassee, Florida, before I went to my 4-year institution. So whatever your plight is in life, you can achieve these things. It just takes you noticing what non-value added and value added decisions are. So some of our industrial engineering classes incorporate statistics and probabilities, something called operations research, which some of the engineering students are all familiar with. We also teach different tooling and materials concepts, and then also quality control, ergonomics, and simulation. At the graduate level, we get into more advanced manufacturing concepts, and then we also materials and energy, because this is what's needed in the future. They want people and engineers who know about different materials and then also know how to apply these concepts, and even energy, because it's very important for our future. So where do IEs work? Well, these are just a couple of places that they actually work at, as you can even see from the video. But basically, we can work anywhere. We're not really held down as far as, say, a mechanical engineer who possibly does one type of engineering his whole entire life. Like I said, we interface with the business structure, so that allows us to encompass or be able to traverse our companies at different levels. Okay, so now I'm going to talk about some kind of off-the-record topics. Like I said, I did come here to kind of speak about minorities in engineering and the opportunities involved, but I want you guys to sort of know the discrepancies here that we kind of have in America. And your part of actually being here is actually be a good community citizen. And part of that is we have to, you know, we have to help each other out. So, no offense to you guys, you're actually a minority now, right? Most Caucasian people are actually a minority. I know. It sucks. No. So we're all minorities.